Hi, Anna. Those are some great questions that you asked. I want to show you what you had for number 13 um, in the worksheet, and then we'll look at that example from the lecture as well. So the worksheet, the problem was negative 24y to the fifth plus 8y to the fourth plus 12y to the third. Now what I have in black and red down here is exactly what you had on your worksheet. That was perfect. The only thing I added was this negative in front because of the negative 24 here. Okay. Now what you pulled out was a 2 squared y to the third. Right? So if I do that, let me get some line going. So you pulled out a 2 squared y to the third. Right? That's what you had in your homework. That is correct. Okay. Notice that 2 squared is the same as 4. So you could have thought of this as 4y cubed that you pulled out, right? Either one is exactly fine, okay? Now what we're going to do is see what's left over. Notice that here I've got 1 term, 2 terms, 3 terms. So there are 3 pieces that are separated by a plus or minus sign. Since there are 3 pieces here, there should be 3 pieces left. In the first one, I've got a minus sign, a 2, a 3, and 2 y's. So minus 2 times 3 y times y. All right, that's what was left after you took out the 2 squared y cubed. In the second one, so now I have this plus sign is here. In the second one, you took out everything in red, and you had left 2 times y. And then another plus sign from right here. You took out everything in red, and what you have left is a 3. Okay. So I factored out the common factor, which was the 2 squared y to the third, which is perfect. And then everything that was left that wasn't circled is here. And notice that there are 3 terms, just like there were 3 terms in the polynomial where we started. Now to simplify this, I would turn the 2 squared into a 4 in the simplified form. And then I would multiply together everything here. Negative 2 times 3 gives me a negative 6, and then a y squared plus 2y plus 3. So all of this would be your answer to factoring out the greatest common factor. Okay, good. You were really almost there. On the second problem, the one that you asked about the lecture, there are different ways to do factor by grouping. What I would recommend, to do factoring where the leading coefficient is not 1, I recommend that you go on YouTube and look for some videos on different techniques, because you might find a technique that's different from what I'm going to show you that you like better, right? And it's totally fine as long as it's correct mathematically. The way that I did it was factoring by grouping. Factoring by grouping requires 4 terms. So the idea is we're going to rewrite the middle term as a sum of 2 terms. To begin, we're going to take the leading coefficient and the constant and multiply those together. So 2 times 35 is equal to 70. Okay. Now, from here, I want factors of 70 that add to this 17. Since 70 is positive, that means both factors should be positive. Since the 17 is positive, let me start over. Since the 70 is positive, both factors are the same sign. Since the 17 is positive, they're both positive. Now you can go through and list all of the factors, which will take a few minutes. So what? 4, 5, and 14, 7, and 10. Is there anything else? 3, 6. That might be it. So from these factors, 7 and 10, are the factors that add to 17. We're not going to use those as our final answer. We will rewrite the 17 as 7 plus 10. So that's 2x squared plus 7x plus 10x. And it doesn't matter if you put the 10x first or the 7x first. You will end up with the same answer. And then plus 35. Now that we have expanded this so that it's 4 terms, we can do factor by grouping. Factor by grouping means group together the first 2 terms, group together the last 2 terms, and then just look at each group separately and take out greatest common factors. So if I'm just looking at 2x squared plus 7x, the biggest thing that they share is a single x. So I can pull an x out front. And what I have left is 2x plus 7. Now I have a plus sign from this plus sign. Between 10x and 35, what's their greatest common factor? Well, the biggest factor that they share is a 5. So I pull that in front. And then what's left is, again, 2x plus 7. Now, this is really nice. The 2x plus 7s are the same. That means that factoring by grouping did work. We need these to be the same, right? Think of this as if I had x times a smiley face plus 5 times a smiley face. At this point, they each have a smiley face that I could pull out front, and all I have left is x plus 5. Okay? We're going to do something similar with this binomial. I have x times a binomial plus 5 times the same binomial. So I can factor out that binomial that they have in common. And then what's left is x plus 5. I have directions on this written out on the handout for today's lecture. So if you want to read through that, there's an example on there you can follow as well. I hope this helps.